Hello. Today we're going to continue with topic 4, statistics. Part 1 of two-part lesson on measures of dispersion. Today we're going to look at the range, the quartiles, and the interquartile range. As shown here in the syllabus, we need to cover the interquartile range, hence the range as well. We need to know about the quartiles. This is the only formula given in the formula booklet, but the interquartile range is Q3 minus Q1. So measures of dispersion measure how spread out a data set is. And the measures of dispersion are the range, or the interquartile range, and later on the standard deviation. A measure of dispersion is also referred to as a measure of spread. And the units of all these measures are the same as those of the variable. So going back over the range is the difference between the maximum data value and the minimum data value. However, it's not that a reliable measure of spread because it only uses two data values, the highest and the lowest. In this example, we're asked to work out the range of the data. So we could simply put the data in order, find the highest and the lowest. And we can use our calculator to do that for us. If we go to Menu, 2 for Statistics, and we can enter in the data. 2.3, 2.1, 2.7, 4.1, 2.9, 4.0, 2.3, 3.7, 4, 5.1, 4.3, 2.9, and 4.2. Okay. So, once the data is entered, if we go to F2 to press Calc, before we press F1 for one variable statistics, we need to go to F6, Set, to make sure that it's set up correctly. As you can see here, it's not set up correctly because the calculator is looking for frequencies in list 2. So scroll down and change that back to individual values by pressing F1. So now the frequencies are all set to 1. Let's exit. And F1 for one variable calculation. You should see here that if we scroll down, you can see that the minimum was 2.3 and the maximum was 5.1. So subtracting those two will give us the range. So the interquartile range is similar to the range, but it looks at the range between what's referred to as the lower quartile and the upper quartile. The median divides the data into two halves, and if we divide the halves into halves again, of course we get quarters. And we do that with the quartiles. So the middle of the lower half is called the lower quartile, Q1, and the middle of the upper half is called the upper quartile, Q3. The interquartile range is Q3 minus Q1. So in this example, we have to work out the median, and the quartiles, Q1 and Q3, and then the interquartile range. So as you can see, the data has been ordered. Okay, there's 13 data values, and we can work out the middle by hand by using the calculation n plus 1 over 2, as shown there. So it would be 13 plus 1 over 2, 13 plus 1 over 2, which of course is 7. So the seventh data value will be the middle, the median. And as you can see, if we count along the data values, we can see that the seventh one is 5. Similarly, we can do this question on the calculator, again by entering the data. So if we press exit and exit again, F6, and then I can get to delete all, F4, delete all that list, and enter a new list. So I enter 5, 5, 7, 3, 8, 2, 3, 4, 6, 5, 7, 6, and 4. Okay, 13 items of data there. Again, press F6 to tab right, and again, and then we get to F2, the calculations tab. Again, F1 for one variable. If we scroll down, we can see that there are 13 values for n is 13. Okay, and we can see that Q1, the lower quartile, is 3.5, Q3, the upper quartile, 6.5, and for this part of the question, the median is 5. So on to the second part of the question. Once the data is split into two halves, okay, we need to find the middle of the lower half and the middle of the upper half. And you can see in the diagram, okay, the lower half has 6 bits of data. Okay, so the middle of that would be between the 3 and the 4. And the upper half again has 6 bits of data. So the middle of that would be between 6 and 7. Hence you can see that Q1 is 3.5 and Q3 is 6.5. So moving on to the calculations, part C for the interquartile range. The interquartile range is upper quartile minus the lower quartile. So that's 6.5. Take away 3.5, leave us with an interquartile range of 3. Similar example here, just a different amount of data. This time we have 10 items of data. So if we exit this, clear these lists, delete all, and enter the set of data. So 12, 24, 17, 10, 16, 29, 22, 18, 32, and 20. Okay, 10 items of data. F6 to tab right, and again to get F2 calculation screen, and F1 for one variable. And again, you can see there are 10 items of data, and Q1 is, or the median, you can see is 19, as shown on the screen as well. And then if I go on to second part, okay, you can see that the middle of the lower half is 16, hence Q1 is 16. The middle of the upper half is 24, hence Q3 is 24. So again, the interquartile range is Q3 minus Q1. 24 take away 16 gives us an answer of 8.